All right. So the assignment. Have you guys looked at the assignment?
Yeah.
Looked at it. Any questions up front?
The one Ryan did you have a question?
Oh yeah, but I think that's on the problem though.
Sure, I'll come back to the problem.
Okay.
I want to just make sure you guys are aware of the assignment. The first one, I'm asking you to prove something. I want to give you a hint or maybe some initial steps. Now think about this. What is this? A dotted with A. No, no.
Product?
Huh? It is a dot product. What is the output? What is the
Like-
answer?
Scalar. What?
A squared.
Huh?
A squared.
It's A square. A dotted with A is not A1. It's A square. Scalar A square. Okay. This is 1. But this is not a unit vector. Right? So this is something you have to know, and that is the reason I have asked you to review the material. And you have to again and again go back to that material and know what you have done. And now you take the derivative on both sides.
Hey, reflexes.
So now you take the derivative on both sides and see if you can solve this. Okay? And you'll end up with that, whatever answer I'm suggesting. You have to justify, and that's where you have to, your review material will come into picture. Okay? The second one, the key term is chain rule. The derivative, right? I'm asking you to do the derivative. I'll just give you one. So, for example, let's say there's a function of theta which is equal to cosine square theta, right? What is the derivative of this? What is the derivative of d over d theta of f of theta? Here it is.
What's the derivative?
This f of theta is cosine theta, cosine square theta. Okay. How do you take the derivative of this?
Square means 2
Mm-hmm.
negative cosine.
No, it's not 2 negative sine theta. So here what you do is, that is the reason you have to understand chain rule. Okay, so here it is like this. You have to look at this as, this is cosine theta square, right? So this itself is some g theta square. Correct?
Okay.
And theta itself is a function of time. So now you're looking at this as G of theta of t, and if I write it completely, it is f of j of theta of t. Okay, and f prime of theta. I'm just giving this d over d theta. F theta. Which is f prime theta, which is equal to f prime into g prime into theta prime. That's the chain rule. So look up this chain rule. Okay. Any questions here? Chain rule, they're just like you have product rule in derivative. You have a chain rule.
Yeah, I've never seen it expressed like that. That's actually kind of cool.
Yeah. So here, if you look at, I'll just give you this. If you take the derivative of this, would be 2 cosine theta. Okay. What is the derivative of cosine theta? Negative sine theta. What is the derivative of theta? So that is the chain rule. So f dot is this. See, f itself, you can write cosine theta as some x, right? What is the derivative of x squared? 2x. So you're going to see that 2x. What is the derivative? If x itself is a function, it will be this, and x theta itself is a function of time, so it will be theta dot. Okay, so this is the chain rule. You have to understand this chain rule. What is the next one? Next one is just basic you have to apply, to do your arithmetic or algebra in this case. Analytically, you have to show that a dot a is a square and a dot b cross e is equal. You have to just substitute, solve for it, and show that this is equal to this. Okay. Got it?
So how is letter A different than number 1? How is letter A different than number 1?
How is a different?
Yeah. So instead of like just plugging these in, and just showing like if we just show these how this equals to a squared, are we doing the same thing out here?
No. That is different. So that you're not plugging in. You're just doing math there. So here you're plugging in a.
Okay.
A dot a. How do you solve for a dot a? With that.
We take these vectors, right?
So how do you solve for that?
You do the x plus ay plus ab dot x.
Right. So what is the output of? How do you solve for it? What is the algebra for that? How do you take the dot product if you're giving the vector components?
Matrix.
No, you guys are. I told you how to take the dot product in class. You don't remember?
Yes.
So tell me how to take the dot product
Of what?
of A and B, let's say.
That's when you do A cross B, right?
That's
That's
cross
not. That's
product.
cross product. It's
Dot
like
product.
it was like 2.
AB cosine theta.
Hmm?
And AB cosine theta.
Okay, you can do that as well. Yes. So what is A? How do you calculate A?
Magnitude of A times the magnitude of B.
Right. So how do you calculate the magnitude of A?
Square them all, add them up, take square root.
You can do that route. Or what is the other route I showed you? Expressing. See, understand there is a difference between just expressing the formula, but solving for it. You're not telling me how to solve A dot A. How do you solve A dot A? If I give you a vector A, how do you solve?
You equal it to 0.
Why do you want to equal it to 0? How do you solve A dot A? Or how do you solve A dot B? I told you how to solve A dot B, remember? We discussed in class.
Cross product. Matrix.
That is cross product, that is A cross B.
Oh.
See, this is where the limitation is. This is where, and this suggests that you have not done the review properly. You have just copied something from the textbook and given to me.
Wait, what could you follow?
Yeah, what we saying?
That's what you have not. That review was meant to be your foundation. So if you don't know, this is the basic where we start. How do you solve A dot B? If you are not able to answer that, then there is serious concern. How do you solve A dot B? How do you take the dot product of two vectors? Do you know? We have done this in the notes as well in the class. We have done this in one of the classes. And that's the reason I want you to go back and review lectures after each class. How do you take, I told you how specifically to take the dot product or solve for a dot product. Go back in your notes and review. See if you can find out from
Is
me.
it the scalar triple products and the vector triple products stuff?
Dot product, that is the first vector operation. That is the very first vector operation.
Right. But he said the AB cosine angle of AB.
How do you solve for that? See, that is the formula. You're given the formula, but how do you solve for that?
Say,
You do it against X, Y, and Z, right? Like you do and then you do X, Y, and Z with it.
So come here. To come here and solve for A, I've given you vector AX, right? So your vector is A equal to AX I
Plus AYJ. Plus AYK.
okay.
I mean AZK.
Now how do you solve for A dot A? Anybody wants to come on the board and do it?
AX times AX plus AY times AY.
Right,
plus AZ
exactly.
times AZ.
Correct. You got it now? How do you solve for that?
Yes.
Oh,
It's
okay.
literally written right here. Okay, that's what you were referring to.
So that is what solving is for. How do you solve? What is A square? Now,
The same thing. Because
Huh?
you're times it, the AX times AX plus AY times AY. Yeah, because you're times it by each other, so it's taking out the vector. So that's why it's scalar.
how is this defined? So here you are just, understand this, here you are just doing AX into AX plus all that, right?
Right.
How is this defined? A square is defined. How is A defined?
How is A defined?
What is A? What is this A?
A is the square root. Under the square root would be A.
This is the
squared.
magnitude of A, okay?
Yeah.
This is a vector A. If you're doing dot product, this is how you do. AX into AX plus
Under the
AY
square
into
root.
AY plus AZ into Z.
Right.
What is A? Square root of
AX squared
AX
plus
square
AY
plus
squared
AY
plus
square
AZ squared.
plus AZ square, right?
Right.
And what do you have? When I say square, this is what I have. Right?
Okay.
This is how you solve for it. Now when I'm asking for dot product, don't give me a definition of cross product. Okay. So this is the very first operation, and that is what I want you to understand from the first review session. You have to know what is the operation. Don't just give me the see. That's the reason I keep on saying, don't memorize that vectors are something which have magnitude and direction. Scalars are something which have magnitude. You're not going beyond that. That is it. That is your knowledge until now about vectors. If you're asked to do a dot product, you're not able to do it, right? I'm not saying you will not be able to do it, but I want you to know how to do it, and this has been done in class. Right? This is the very first operation you have to learn how to do. Correct? And that is what you need to do. And now think about, this is the very first problem, right? In that, the first part of number 3. Now, how do you go about doing B part?
Are you looking at it, Jamal? What's the B part?
It's A dot B cross C.
That's the triple product.
Okay, but how do you do it? It doesn't matter whether it's a triple product there. How do you do it?
That's what I'm asking. Is that what you're talking about?
Analytically, what do you mean analytically?
Analytically.
It's a triple product, yes. So what?
So
Can it be done? Can it be done?
Yes.
So you would just do, well, you do your cross product first, it would be
the bottom
B
half
cross C. I'm looking at the problem.
Yes.
So it would be B cross C, which is B.
Which you do the vector way, the matrix way. That is where your matrix way will come.
Okay.
Okay. And then you do the
Dot
the vector
product.
times
Dot
vector.
product.
Yeah.
and then you do the other side of it. So when you're trying to analytically prove, you do the left hand side and the right hand side,
Yes.
and you show that left hand side is equal to the right hand side. Got it? Or we start with left hand side, okay, and show that, deduce it to show that it is equal to the left hand side. Okay, by substituting, this is essentially substituting vector A, B, and C. Analytically, you are just substituting those. Okay. Now, part C, you're not necessarily substituting. Part C is more about, so how do you do part C? So look at what part C is. Okay, it is A cross B dot C cross D.
So
So you do all the parentheses first.
use vector identities to show.
Vector identities. Now, what are vector identities? What vector identity are you going to use here? There are a bunch of vector identities we discussed. I gave you a bunch of vector identities on the board. This. So what do you look at when you look at this C, part C? What do you see in there? What is that? What?
Cross product dot cross product is equal to dot product minus.
Can you envision that as a triple product? Or can you transform that to a triple product?
Yeah, you solve for all the ones who are going to be vectored first. If you solve for all the ones that are going to be vectored first, and then you do the ones that you know are going to be scalar.
It could be seen as a triple product, or it could be seen as a simple dot product.
The whole thing.
Yeah. Because what is parentheses? What is the outcome of the parentheses? Of the first, it's a
I
vector,
can't see it.
right? The output of, so you can see the parentheses as dot product. If you solve for both the parentheses, it's just one vector dotted with another. If you solve for one parenthesis only, what does it become? Vector. It becomes a triple product. If if you solve for just one parenthesis among the two, what I'm trying to say is it's A dot, it's A crossed with B, right? Dotted with C crossed with D. This is how it is, right? Let's say this is E dotted with F. This becomes A cross B could be E, right?
Yes.
Some vector. C cross D is some vector F. This becomes a dot product.
Yes.
But if I only solve for one, this becomes a
Triple product.
triple product.
Okay, then you solve for the cross product, then do this dot product.
So what you want to do is, you want to manipulate it like this. Okay, so remember the vector identity we used here. What is the vector identity we need to use? E dot C cross D, or I talked about cyclic rotation. So you have to use cyclic rotation here. Do the cyclic rotation, and once you have done the cyclic rotation, substitute back E, you'll end up with something like that. Okay? You remember cyclic rotation? You don't remember?
Change everything in
C
order.
dot, C dot E cross, C dot D cross E.
Right. If you do C dot D cross E, right? If you substitute E back, it will become a. You do C dot D cross E, right? If you substitute E back, what would it become? It will become a vector triple product.
Oh.
And then what is the vector triple product identity? You remember the vector triple product identity? Back minus cab rule. Do the back minus cab rule.
Do what?
Back minus cab rule. That is the other vector identity. So you remember A cross
CAC minus
A cross B cross C. What is this equal to?
CAC minus CAB.
B
Oh, the back cab rule?
back cab minus cab.
Is C a vector?
Yes. Only this way you can get to that identity on the equal to on the right hand side.
Wait, how did you do the cyclic thing?
So you do the cyclic thing. If you do the cyclic thing, what are you going to get?
You're gonna get C dot D cross E, right?
D cross E, right? If you substitute back E, what are you going to get? C dot D cross.
A cross. Oh, okay. Now I see what you're saying.
You apply back minus cab rule here. Only then you're going to end up like that.
Okay.
Otherwise, you're not going to. Okay. So here you're not solving for anything. You see, you're not doing any. Are you solving for anything? You're not. Are you substituting anything?
Yes. You substitute the
Right, but you're not necessarily, and you're not analytically solving. You're not inputting anything. Okay. You're just using identities to manipulate identities. This is actual math. So this is just understand what is the difference between. So here, this is math. Okay. This is simply when you do this. This is arithmetic or algebra. You're simply substituting. Okay. Here you're actually manipulating math. You understand the basic principles or basic laws of mathematics, and you're manipulating that mathematics to go from one representation to another and trying to verify if those two are equal. Alright? Will you do this? Any questions, Jessica?
So if we bring both sides to look like so let's say like we have both sides like right here, and we bring them both to look like the back cab.
Yeah, what you do is you start with the left hand side
Uh-huh.
with this, you substitute and then what you'll end up is the right hand side.
Oh, okay.
Okay.
So we should
All right, cool.
See that? Any questions?
I'll have more tomorrow. So it's not as bad as it looks. Like the homework. It's just not. It's not. Question: do you want us to do this example on page 29 and turn it in, or is that just like?
Yeah, do that as part of your homework 1.
Oh, it is okay.
What does that do? What's that do with this before the test?
Do it along with homework 1.
So yeah.
So Monday, by Monday, give it to me.
Okay, so that, okay. So you want that one and assignment.
Assignment 1, yeah. Assignment 2, yes.
And page 29 should help us understand.
Yes.
Put all this in. Okay. Sorry.
Test is
I
next.
did that for my own
Test is
record.
next.
Test is at on Wednesday.
Oh, Wednesday.
Do we get back our quizzes and homework in here to study for the test?
Not the quiz. You'll get the. I'll try to grade your homeworks as soon as possible. Okay. Or if you just need your graded homeworks, just come to my office and say sit and say I need the homework graded now.
I did that problem for my homework. I just gotta do it for.
Next one. So next one is
Hey, I'm on it, dog.
it's 1.4.
Thanks.
1.2.
By 2 and 1.3.
No.
So you like making me do it. So you leave.
That's fine.
Alright, so 1.2 is the same thing. Let's look at 1.3. Okay, so this 1.3 is a very, very interesting problem. Do you guys have the textbook on your hand? You don't have the textbook or that.
What chapter?
Chapter 1.
1.3.
Mr. Clark.
Chapter 2.
Alright, what it says is, so there are,
Sorry, Brian.
So by scalar projection, we're calculating like the actual magnitude line.
projection is not necessarily the magnitude. So I told you the projection is the shadow, so to say.
Okay.
So if you have this, okay, yeah, if you have this, the shadow from here on the ground.
Oh, okay. Okay, cool. And like on a certain plane.
On a certain line.
Okay.
Okay, that is a projection. So you have there are 3 vectors, A, B, and C. Okay? You see that?
Yeah.
Make sure you look at the this thing. Listen. Otherwise, you'll not follow it. If you don't look at it, it's going to be very challenging to follow. So make sure at least you look at some
Which figure?
figure.
It's page 53. It should be on top of the page.
Okay. So you look at vector. There are 3 vectors, A, B, and C, right? Is there any relationship between the 3 vectors?
They share the same origin.
They have the same origin. Okay.
Because A and B are on the same plane.
A and B are on the same plane. Yes.
But C is not perpendicular to either.
Right. So none of the vectors are perpendicular to any of them. Page 53. You're looking at that. You're looking at an older textbook.
A specific
Yeah.
relationship.
The other one's on my computer and in my room.
Chapter 1.
Yeah, so chapter 1.
Yeah,
it's
I think
section
you passed.
1.2. So
Yeah, problem section 1.2.
Problems.
What is what you put?
Okay.
this section.
Matter of fact, I did get that for real. That's sad, bro. I'm so sad. But I did bring my trunk from home, bro. I've been cleaning out.
You don't have a problem section. The problems is missing.
Nah, I'm trying to start with
So you
getting
only
to
have
that
the
shit, man.
main section. Chapter problems.
I need to get a mute.
I have the book, the actual book in my room.
Yeah, I got like,
Yes, it's not.
I think I got some oil, bro.
It's not
I got
I
some
just
oil.
use my.
Just go. Somebody share the book with her, or
It's good.
Wow.
It's
Jamal. Why don't you go and sit?
It's team, man. It's team much, you know what
SN and Alright, so look at the two vectors. Okay, this is a very interesting problem. There are three vectors essentially there: A, B, and C. There is none of them are perpendicular or anything. A and B are in one plane, or any two vectors will always form a plane. What is being asked?
Calculate the scalar projection CAB of C onto the plane AB.
Okay.
See instructions below. It says hint C squared equals C squared N plus C squared AB.
Okay. Now, the projection is always a scalar. Now, keep in mind, the bold letters there are vectors. Okay, and the non-bold face letters are scalars. So the scalar projection is always a scalar. Vector A, B, C are vectors. So it's bold. If you take the cross product of A and B, what do you get?
Vector.
Cross product.
Of A and B. Look up there and tell me.
Of A and B, you get CN.
Yes. So you get a vector.
That's perpendicular to A and B.
Yes. So if you have A and B, if you take the cross product of A and B, you see that?
Yes, thank you. Sir.
Okay. You get that.
I remember that.
You have some A and B here. Okay. If you take the cross, this is what you're going to get. Right? This is some vector C. A cross B divided by A cross B is what? There's a vector there for this. It's in there. The notation is in there.
Oh, you win.
UN.
Yes.
Good.
Just right.
You get this? Everybody gets this?
Yes.
So you have, this is that vector, A cross B is this way. What is B cross A? The other going down.
So I was UN not team.
Huh?
I was UN not team.
Not?
Team. I mean, they're labeled like two different things. So are they two different things?
Yes. So UN is UN.
Oh, yeah, because UN does it.
It's a unit.
It's a unit vector.
It's a unit vector. Because I divide by magnitude, it becomes a unit
Like
vector.
it's a TN.
Okay. Now,
Shit got a nigga on my breath.
you see, what is the projection of C and on UN?
So,
That is also there.
you said
Does
it-
C?
CAB?
you said
C.
projection of UN onto what?
The projection of C onto UN. CN?
Cn. The shadow.
Oh,
You see that?
So you're trying to make A, B, and UN like the fixed plane while you're trying to find C, right? So are we making A, B, and UN like a fixed plane so we can find C to find a projection?
So Cn, the projection of C on Un is Cn.
Okay.
Got it? You see that?
so,
And
never mind. Sure.
you got it? And the relationship they have given you is C is equal to Cn square plus CAB square.
No, C squared.
Keep in mind all these are
Scalar.
scalar. You cannot take vector square. That's not permitted. Okay. So what is known now? You are ultimately required to calculate this. You see that? That's what is being asked. The projection of
Yeah, CAB.
CAB on, or projection of
On the AB plane.
AB plane.
Yeah.
Okay. So if you, do you know this? Can you calculate this?
Yeah.
Can you calculate this?
Yes.
How do you calculate this?
The A cross B squared. Wait, like A cross
A cross B.
C cross D.
And just A cross B.
CN is
What is Cn?
The projection of C on
The CN is a projection of A cross B.
So we gotta do. So we divide.
That's
C on
That's a perpendicular to A cross B.
My bad. That's what I meant.
Un is a perpendicular to A cross B. Cn is the projection of C on this.
To UN.
Dot product.
Huh?
Dot product.
So we
That's
can't
what you have
calculate-
to learn. Yes. So go back. There's a formula for calculating the projection, and projection we have done actually the projection in class. Okay. So go back and review the class. I told you how to calculate if there are two vectors A and B. I told you how to calculate the projection of A on B and B on B.
Yeah.
So just go back and review that. You'll know.
That's when we transpose the matrix, right? Like the matrices.
the CN is a scalar and UN is a unit vector. So it'll still work.
Now the projection of,
It's like the vector and the unit vector, right?
I'm talking about projection of C on UN.
That's CN, right?
Hmm?
That's CN, right? Isn't that CN?
So you have to calculate that. The projection will always result in a scalar number. You get the approach?
Yes.
Okay. So you have to do that. What is the next one?
Seven on page 50.
So that is again the big problem you have, I think you guys have to solve, right?
Calculate the Earth's gravitational distance equal to the moon's orbit. This is the question. I'm telling you. And nobody,
1.1.
he's like, we got to answer crap like this.
Right. So this is the
That's what I'm saying. Like, I can calculate on the moon stuff. I can calculate how fast you're going.
Now, what I would suggest you to do is try to do this. You'll understand your previous problem much better because this has numbers.
So do this first, and then you go.
Yeah. Whatever we did in class was abstract.
Yeah.
Okay. This has numbers, so you'll actually be able to solve this much better.
I mean, we had numbers for the one in class too.
Okay. So let me first look at the last problem. Let me make sure.
We can do this, guys. Don't worry.
This one looks
Oh, I
rough
got it.
right
I
now.
got it.
All right. So we have the. I'll come back to this. Let's look at the next two problems. Problem number 6 there are three vectors A, B and C. Okay? What is the condition for them to be coplanar?
Okay. So A and B and B will get C on it.
If you take the cross product of any two vectors,
You end up with
will those three vectors, for example, let's do,
you took the cross product of A and B.
so if you take A, B and U, can they be coplanar?
What do you mean when you say coplanar?
In the same
on the
plane.
same plane.
So if you have A cross B equal to C, okay? Can A, B and C be coplanar?
It wouldn't be, no.
Can A and B be coplanar?
Yes.
Can B and C be coplanar?
Yes.
No, because
Yes.
is it a
Yeah,
cross?
B and
it
C.
will form a plane.
Yes.
Always remember, any two vectors will always be coplanar
Yes.
because you are not defining the plane.
Okay,
You understand?
I got you. So basically, like my finger and my thumb,
Yes.
no matter what
Do
I choose,
anywhere that's a plane.
it's always gonna be okay.
Yeah, you do this, you do this. They are, essentially they are plane, right? This you can define them. You move your plane, your sum anyways. It'll be plane. But if all these have to be coplanar, or just take three for example, just take these three. Are these coplanar?
Yes.
Almost.
Yes.
Are these coplanar?
No. Wait. Yes.
No. How can these be coplanar?
Oh, okay.
Because those two they're going the same
Yeah,
way,
because
right?
that
And
one
then
is
that
like 90 degrees.
So it's like two. It's like two vectors
It's
basically.
like 2.25.
Because
How is this a plane? This is not a plane. This can you put these on one plane?
No.
Oh wait, no, never mind.
Are these coplanar? The palm of this thing is a plane, okay? Only when you're doing this, all your five fingers are in the plane. If I do this, are they in the palm, in the plane of the palm? No, right? So what is the condition for three vectors to be coplanar? Think about it. This is
Three vectors to be coplanar.
That'd be parallel.
Hmm?
That'd be parallel.
Three vectors will be coplanar.
Hmm.
That what you They're all on the
Coplanar
same
means they're on the
plane.
same plane.
in the same plane, right? How do you evolve or how do you come up with a condition? Okay, so think about this. Let's look at this A, B, C. Okay.
Those are coplanar.
A and B, yeah.
No, A, B, and C. If you
They're not all coplanar together.
Look.
A is coplanar.
Again,
with
it's a perspective, okay? Because he's seeing this as a flat plane.
yes,
He's not looking at the 3D perspective of
no.
this. Okay, but otherwise, if you're looking at a 3D perspective of this, okay, if you are being a little more than just see, if you are looking at this with your eyes, of course they are, but if you're processing the image in your head, then they are not coplanar. So our eyes are, it's very interesting. Your eyes cannot see 3D. You know that? Your eyes are not designed to see 3D.
Yeah,
But
we
I'm
use
Batman.
shadows
Huh?
and stuff to
That's what
Yes.
we see,
put
right?
on Batman.
The image is processed in your brain to make it look 3D. If the image is not processed,
Yeah.
you will have no perception of depth.
Yeah, that's
Oh,
what we
yeah,
got
you
too, right?
put out
So
depth
we can
perception.
Like,
But
number
that has
one
to be processed here. So whatever,
Yeah.
because it's a simple optical device.
Cyclops
Okay.
babies.
So that's the reason if something is far off, you are not able to figure out
The depth
the
perception
depth
of it.
perception
So
because
if I
your
had-
brain is not processing that.
If I had a third eye, would I be able to see 3D?
It has to be processed again. All that information has to go and get processed. Even if you have multiple this thing, it has to go and get processed.
Gotcha.
So how do we make all of these coplanar?
Right. So what you have to look at is, now let's look at this as a 3D perspective. Okay. If you take A cross B, you get this,
Yes.
right?
Yes.
Now, let's say if you take the, let's say C is in the plane of AB. This vector will be
B
this-
cross A.
no, this vector. Now, if you take the cross product of A and B, is this vector perpendicular to A?
Yes.
It has to be.
Yes.
Is it perpendicular to B?
Yes.
If C is in the plane, will it be perpendicular to C?
Yes.
So, what is the dot product of two perpendicular vectors?
Dot product of two perpendicular vectors gives you one that lies in the same plane. That lies in the plane.
So, think about the definition of dot product. A dot with B is what? A
AX plus
A B cosine of theta. What is theta?
The angle between the two.
The angle between A and B. If the angle is 90,
So it just goes like diagonal. It's a resultant.
if the angle is 90, what's up guys? What is cosine of 90?
What's one?
It's 0, Jessica.
It's 0. I'm sorry. You called my name out on the video. You know, people are going to be looking at this Dr. Sunday.
It is 0. You see that?
Zero.
Yes.
Yeah.
If you take A and B, okay, you get this. And if you dot it with the third vector, and if that is 0, all the three are in the same plane.
Okay.
So it's the same line.
Cross dot.
So essentially,
So you have to
the
UN dot.
So you do A cross B, and then C cross B or A. It doesn't matter. C dot A, B or A. Okay.
So wait, so it'd be A cross B, which
Mhm.
is UN, right?
Which will give you that third.
sure, no, that's not. Okay, so just understand this. It's the condition is in here. Okay, it's on this board. I don't want you to give the condition because that is the answer.
Yeah.
Okay.
So this is
Everybody
the
be
answer.
quiet. Especially the people who just came in the room.
It's what?
Please don't be quiet.
Yeah.
I don't know.
Y'all shouldn't have had a class. I'll talk to you about that later, right? I'll talk to you about that later, you guys.
It says on the board. So
It's
I'm not seeing it.
It's not.
You'll see it. Just think about it. If you we'll meet tomorrow, and I'm going to be here Friday. So if you still cannot figure out, just come to my office. I want you to come to my office. I don't want to give the
I'm
answer.
gonna be there.
All right, let's do the last one. So the last one. Look at the last problem. What is the last product?
Oh.
Last problem.
So
So you have U, T, UN, and U. You have three vectors here, okay? UT, UN, and what is the relationship given to you? U. What is the relationship given?
Oh, it's UT cross UN is equal to UB.
Cross UN is equal to
UB.
UB. Okay, and what are you required to prove?
UB cross UT equal to UN.
UB cross UT is equal to UN.
And
Right, so let's look at this first. Okay? This is a relationship which is given to you, right? Are they orthogonal? Does it say they are orthogonal? are perpendicular. So UT, UN are perpendicular. So all these three are perpendicular vectors. They form an orthogonal basis. They form actually an orthonormal basis because these are unit vectors. Does it say they are unit vectors there?
Yes.
Okay. They form the orthonormal basis. So you can say IJK. All right. How do you go about doing this?
I mean,
You can't keep
That's
on
just
the
true.
back half thing until they match up.
How do you do the back minus cap? How do you get to even back minus cap? Because there is, do you see a back cap application here?
I mean that's just true.
Thanks.
It said in the first statement that they're perpendicular, and kind of just already know it.
I'm sorry, I know I can't link, but what is the back? Y'all said Batman's what?
Back cap.
Back half.
Oh,
It's on
you know the back
page.
half?
I
Look
don't.
at that little corner right
It's
there.
on page 9 in the book if you want
Oh.
to read it.
Now that we have discussed this, that's the reason I'm asking you guys
It's
to
on the corner.
go back, review your notes, review your lectures. See, this is an indication that you're not reviewing your lecture. Neither are you reviewing your notes. At least go through your notes when you go back. Evan, you have to make sure you go back and review your notes. Back minus cap we have discussed in class.
Alright.
Okay, so please go back and review. So here, look at that. Okay,
True.
UT, you're given UT crossed UN is equal to UT, right? This is given, and you're required to prove that UB
Oh, I
cross,
know what you can do.
yes.
You just plug it in, and then you just. That's
What are you
when
going to plug in?
You plug in that for UV, right? And then it's like on the cross product.
I mean, like it's already explained because it says in the first statement that it's
That is another way of looking at it. Yes. So what you can do is, if you want, that's a good point, Simon. So do this.
Good job, man.
What is this? So what is UB?
UT cross
UT crossed with UN crossed with UT, and now you have to prove that this is equal to UN. So here you can apply
the back half.
back cap. You can do that. Yes, that's a very good way of doing it. So you can do that.
And just to be clear on the other one, so like you say the plane's like this, since it's 0, now they're like this. So they're all the same plane.
No.
Understand across from that, doesn't the question become a rhetorical question, really? Like, if you understand the cross product, you already know this because it says they're perpendicular.
Because it's just asking if they're coplanar or if they're not. So you just write it's coplanar or it's not.
You write the condition and show that it's whether they are coplanar or not.
Good question.
Mm.
What a vector cross, like what would A cross A be?
What would it be? Tell me.
It would be 1, right?
A cross A.
Yeah, A cross A.
Think about it.
So 0.
What is the definition of cross product?
It gives you a vector that's perpendicular to the
Definition. Tell me the definition. Recall the definition, and when I say definition, give me in terms of sine and cosine.
of a cross. Nah, I ain't got it. I would be fishing for nothing.
It's A sign.
Anybody cross product definition?
Oh.
It's just A sign theta.
Yes. Definition of A cross B is A, B, sine theta, and the vector, which is perpendicular to A and B.
Yeah.
A cross A, right? You're talking about. What is the angle between A and A?
0.
What is sine of 0?
0.
A cross A is?
0. Okay.
Got it?
And
That defines, that immediately gives you that
okay,
0.
but last question. And 0 cross a vector is 0 cross a vector 0?
Mhm.
Okay.
So here,
Nailed then. I was gonna try to use the
cyclic rule does not apply to the
but
triple
it
product.
doesn't, it doesn't work.
Yeah, it only applies for the
Yeah.
scalar triple product. So here you have to use the back cap. Got it?
I got it now.
So if you use a back cap rule, you'll end up with it.
So that's
Alright, so now again going back to the coplanar. Think about this, okay? You see two vectors here? Everybody sees two vectors here?
Yeah.
Are they in the same plane?
Yes.
Are these in the same plane?
Yes.
Andrew? Marcus? Are these in the same plane?
Yes.
Any two vectors are always in the same plane. Okay. A third vector. It becomes interesting when you talk about the third vector, right? There's a PH.
Thanks, Mark.
Are these three in the same plane?
Yes.
Are these three in the same plane?
No.
Are these three in the same plane? No, right? Are these three in the same plane?
Yes.
How do you prove that these three are in the same plane?
They're all
Plate.
at, they're all
How
at
do
the
you
same
prove?
angle.
Mathematically, how do you prove?
I'm done with you.
Mathematically, you do the cosine thing. Because that was 0.
How you can take cosine between three vectors?
And you can't like do the.
Say
That's what I explained to
You
you.
get okay.
So
Didn't we do that? We did that last time. You do the cross of 2, and then once you get to perpendicular, you do the other 2, and it should give you the results.
But that's how you prove it.
Yeah.
Okay.
So you
Say what we found out.
Oh,
Say
so you
what we
find
found
the
out.
so you find the U
Okay.
the U in of
You can take any two vectors, okay? Take any two vectors. Take a pick. What is a cross?
Blue and black.
It's perfect.
Blue and black, right?
Yeah.
What is a cross of blue and black? Sorry, blue and blue and black.
It's gonna be perpendicular. It's gonna be straight down.
Down,
Yeah.
right?
Oh, yeah.
Black and blue,
It's gonna be up.
right? Now, how do you know if this is perpendicular, or if you take if this is in the same plane, will this be perpendicular to this as well?
Yeah.
Yes.
So you can use the cross product or dot product between these two to figure that out. You got it?
Yes.
That's
Yeah.
makes so much more sense now.
Got it?
Yes.
So that's what you have to do.
Here we go. Bonus time.
So that is the application of vector mathematics. And this is a very, very fundamental application. And if you want to, I want all of you to be sound aerospace engineers, space engineers. You have to go beyond this at some point. You have to, it's not going to come to you right away, but you have to keep that thinking. See, now you're thinking. You're applying and thinking. And you have still a long way to go towards that applying and thinking. And that's what this training is for. To be able to teach you how to think. It's not about all these identities, right? I'll give you all the identities, all the formula. Can I give you thinking in the form of paper? You should know how to apply what is known or what is developed. You should know how to apply the cross product, or how to apply the definitions or what it means, right? If I give you a bunch of, it's like, I'll give you a bunch of words or a bunch of letters. How many letters are there in the English?
26.
26, right? How many words are there?
Too many count.
Too many to count. How many ways you can put those words?
More than too many to count.
Yes. So it's defined upon. It depends upon your capability to put those words together to form a meaningful explanation, and that's what math is about. I can give you the fundamentals. Math is also like a language. I can give you the identities, I can give you the formulas. But if you are not able to think in terms of mathematics, having even a big book of those is not useful. Doesn't mean anything if you're not able to apply it. Okay? So we'll quickly look at the last problem which Rodney is looking at, or all of you. Okay. So where are you stuck? Tell me, where are you stuck?
That's what the boys are waiting on. I'm stuck at the.
It's a lengthy one. I'm going to give you that. It's not difficult per se. It's just a lengthy one.
I'm stuck at the solving for IJ and K.
Okay. So here, so tell me what you can do is, all right.
We know. I think everybody knows all the information. We can just start with the vector.
Can you look at this?
Alright, so
Cramer's rule.
Grammars, yeah.
So if you're given, let's say, okay, what the unknowns here are x, y, z, right? Cramer's rule will allow you to put this in the form of matrix: A1, B1, C1, A2, B2, C2, A3, B3, C3, and solve for this, or solve for x, y, z. If you want to solve for x, okay, let's look at this as it's engineering math. Yes, all of it is engineering math. Whatever you do is engineering math. Any math you do here is engineering math. Right? So here, this is what you're solving essentially. Correct, Rodney?
Yeah.
So if you look, you have to look at how to solve. How to use Cramer's rule to solve this. Typically what you will do is, you look at, let's say you look at first two equations, and try to cancel off terms, and whatever you get, you put it in the third equation and solve for that. Solve for C. But using Cramer's rule, you can make it much simpler. Did you look up Cramer's rule?
Yeah, I'm finna look it up.
Yeah. It's a very simple way to solve for.
I might have a notes on me right now.
Yeah.
I'll look for one of
Cramer's rule is not was not discussed in class.
I'm
was,
talking about engineering math. I got the weight equation right here. Hey, did it come after or before the philosopher?
Probably after that. The matrix is
About this here right here.
It was a
The matrix
third
is-
test. It was a third
the
test.
second test
It was?
with the matrices.
Oh,
it's a set of simultaneous equations. Here you have to just look at it as
Yeah, I found it.
three equations and three unknowns.
Yeah, I found it.
So here, what are the three unknowns?
Exist.
XYZ?
I'm so mad, bro.
Which XYZ?
Oh,
The small XYZ. The capital here, keep in mind, see, look at this. just pay attention here a little bit, everybody. The capital XYZ, cap XYZ are expressed in terms of small xyz. A1, B1, C1 is known. They will be just numbers. Okay. What you need to do is understand how to express small xyz in terms of capital XYZ. You understand? And for that you have to use Kramer's. What are you solving for here? What are you solving for?
Big I, big J, and big K.
Here what are you solving for, Rodney?
Oh, X, Y, and Z. Little X, little Y.
Little x, little y, and little z, yes. That's what you're solving for. Got it? So now you put that in context of the I, small I, j, k, and cap I, j, k.
I see it now.
Okay.
Yeah, I'm a little hot about that one.
Alright. Any questions? Any further questions?
Office hours tomorrow?
Yes. Today, tomorrow. Cool. So make sure you come by and get your Jessica. I want you to come to my office to clarify your doubts.
To clarify my thoughts.
Yeah.
Yeah.
You need a coffee.
I'll be there. Yeah, I did.
I think you've not had your sleep.